So for assumptions, there's always 3 assumptions you are answering this in the homework over and over again. Okay, so we are discussing procedures for estimating and test hypothesis about population parameter when there are 3 assumptions. Okay, the observation in your sample x1, x2 to xn are independent of one another. And we're going to explain this later. And B, the observation are a simple random sample from the population. 3, the population is normally distributed. And using the t or chi-square distribution to calculate confidence interval or p-value can have some incorrect conclusion when the assumptions are failed. Okay, so for assumption 1, simple random sample of observation. So that be random, right? Okay, so this one, this should be this B here. Yeah, so cannot assess based on the data alone. So that's why when people ask me a question about homework, I say, well, depending on all the information given, I can't really say that. So you probably need to know some background knowledge of how this data was collected. So sometimes we cannot say if it is a random sample based on the data alone. We need knowledge of how the study was carried out, and we need to look carefully at attritions and other exclusions that make the sample unlike the target population. So this means we still do this is a population and this is a sample, right? Or this can be the sample, or this can be the sample, or this can be the sample. So there are a lot of different ways to sample. Is the way you do the sample completely random? Okay. And so most samples are not random. Study implementation need to be reported in detail, and other investigators can then assess how well your results are likely to apply in their setting. So this means, So this means when you are doing this is the whole population, and you are picking up a lot of sample. Sometimes when it's not, you're just selecting everything here. That will be not random. Are you selecting samples from population at random? If it is, then this criteria is met. Right. And then next one is independent of observations. This assumption usually assumed without formal examination in the absence of indication to the contrary. Sometimes it's not really true when we are all the data contain multiple members from a family, or you are measuring my measurement again and again, like how before and after, or day 1, day 2, day 3 of all my measurement, and then someone else. So any lack of independence must be taken into account in analysis, or the conclusion will be highly suspected. So if we're doing, let's say I'm interested in how much water do people drink, and independent means how much water I drink every day have no effect whatsoever on how much water you drink every day. So we are independent. But if we are in the same, if we are living together and I'm always drinking water and I always tell you to drink water, then probably it is dependent. So this normally what we assume is independent, unless it's not. And then normality. So this is kind of rule of thumb. How do you define normality? So if n is smaller than 15, we're gonna use normal based test like t-test or chi-square test if there is a strong evidence of normality. Or we're just gonna use a non-parametric test. This is not something we learned yet, so don't worry. And then if n is between 50 and 40, we are going to use normal based test unless there are outliers or strong evidence of skewness. And if n is greater than 40, we're just going to use normal based test unless there are so many outliers. So the good thing is t-test is always robust. So that's why sometimes we can use t-test, we can use z-test. Well, it's kind of, if that's the case, probably the result is not gonna be different, but t-test is always robust. So you can check assumption for normality is knowledge from prior sample. So when we're doing questions, this is not really something we know, but in real life this happens a lot. And then graphs. So what you can do a QQ plot and you can do a histogram. Oh yes, here you can do a histogram. And then there are tests. This we didn't learn, and I didn't really conduct a lot of this kind of tests, so just it's not really a big deal. So here are all the 3 assumptions. So next time you do something, check the assumption. Okay.